Okay, so this is going to be a review of carboxylic acids and esters. We covered this first after we got done with carbohydrates. And as you see, this relates to lipids because fatty acids are carboxylic acids and triglycerides, and waxes are esters. All right, so what they have in common is, so the group, this is called a carboxyl group, this guy right here. Okay, so carboxyl group, all right? And what a carboxylic acid is, it has an H hanging off of the end of a carboxyl group. Sort of like an aldehyde had an H hanging off the end of the carbonyl. Okay. Now, we're not getting into the reasons why it's called an acid, but it's called acid because this H can come off. And when it does, and that's the definition of an acid loses an H plus when you put it into water. Okay, so we'll cover the carboxylic acids first, and then the esters. Okay, so what I'll do is I'll go over some common carboxylic acids, and then we'll do some practicing of naming maybe some uncommon. But notice here, this would be our first carboxylic acid as one carbon. It's called formic acid, and we're going to see that, I'll show that in a minute, is that it also has a scientific name, methanoic acid, which we do not call. But remember, formaldehyde was a one-carbon aldehyde. This is a one-carbon carboxylic acid. And I told you it's got a distinctive smell. If you've ever been attacked by bees or ants, you would definitely know you smell it. All right, acetic acid is a two-carbon carboxylic acid, also known as ethanoic acid, and this is the main component of vinegar. So other guys you've probably heard of, and you don't have to be responsible for. You have to be responsible for these two guys, and I'll go over them in a minute. Yeah, this citric acid. You've heard of citric acid, like citrus. Plants like oranges, etc., but it also is involved with the breakdown of glucose. Remember we talked about the citric acid cycle or Krebs cycle. That's involved with it. And there you go. And then you probably heard of lactic acid. For instance, you may have heard in terms of exercise, but also you may have heard of it is that if you have a high level of lactic acid in like your heart, it may cause heart attacks. It's also been implicated with cancer, but it doesn't mean that exercise forming lactic acid causes cancer. That's a different type of thing. Okay. As we've seen before, when we talk about fatty acids, the fatty acid's a long chain with a carboxylic acid at the end. Another place that we're going to see fatty acids, carboxylic acids, is when we talk about the next material, amino acids. Okay, what I'm going to do now is I'm going to go through some naming of carboxylic acids. Okay, so I'll start off with the first one. So the first one you have to know is this guy right here. And we just showed this. Okay. And this is formic acid. Okay, technically that is its common name, and we know that, but it also has a scientific name. One carbon like methane, oic acid. And we're going to see in a minute that carboxylic acids will end in oic acid. Okay, 2 carbon. It doesn't matter how you draw it. I could have put the OH over here or over here, doesn't matter. But we just saw this guy known as acetic acid. Okay, but it's also known as ethanoic acid. This is the name I want you to know about it. Acetic acid. Okay, so let's do a couple other ones that aren't so common. So given a name, you can come up with a formula or vice versa. So let's see if we don't get the name of this guy right here. And we're just going to do a few of these. All right. Okay. First of all, you know it's carboxylic acid. This is this guy down here. And 1, 2, 3, 4 carbons. So this is going to be a butanoic acid, butane 4. The numbering always starts with the carboxyl. So this is 1, 2, 3, 4. So the ethyl coming off of number 2, and the methyl coming off of number 3. So 2, 3. So the naming is simply 2-ethyl, 3-methyl butanoic acid. And I know I went over 4 or 5 of these when I covered this before. Okay, so that's it for carboxylic acid in terms of their structures. All right, now there is one chemical reaction I want to make sure you know. Okay. All right. Now, in the last chapter, we talked about taking a primary alcohol, oxidizing it, having it lose 2 hydrogens to form an aldehyde. Okay. All right. And this particular reaction here is ethanol is converted into acetaldehyde when it uses hydrogens. And this happens when you drink booze, okay? When you drink booze, the ethanol goes to your liver. Ethanol is what makes you drunk. It's the alcohol we call alcohol. Goes to your liver and it gets turned into acetaldehyde. Your body's breaking down the ethanol. There's a further step that can happen to the aldehyde, and that's in the presence of oxygen. It can be further oxidized. And I told you there were 2 ways you can oxidize. You can oxidize by losing hydrogens or gaining oxygen. So what you can do is you can take the aldehyde and add oxygen into it to form a carboxylic acid. And in this case, you take acetaldehyde and add oxygen to form acetic acid or vinegar. So this is actually how they make vinegar. They take wine or beer or hard cider, and what they do is they just expose it to oxygen. It'll undergo oxidation, turn it into acetaldehyde, and then finally turns it into acetic acid or vinegar. So you may have heard of malt vinegar, wine vinegar. That's how they do it. Also, this is what happens in your body when you break down booze. First it gets turned into acetaldehyde, and eventually gets turned into acetic acid. So if you drink a lot, you may notice the day after you smell a little bit like vinegar. Okay. So know this reaction here. You take a primary, the aldehyde, to carboxylic acid. Now the ketones cannot be oxidized like this because you can't get oxygen on the end. Okay, so that finishes the carboxylic acids. All right, now I'm going to review esters. Okay, esters, they have the carboxyl, but what the carboxyl is trapped between carbons. Ours means carbons chains, okay? So you have this guy, and you have a carbon chain over here and a carbon chain over here. Carboxylic acid just had an H over here. Okay, so what we're going to do is get naming, but the way that we go about naming, learning how they're named, is how they're made, or esterification. All right, again, why are they important? Well, they're important because what we just talked about with lipids. Triglycerides are esters, waxes are esters. Okay. What I'm going to do is I'm going to show on the board this reaction, and then come back to this slide to show you how it relates to it. So we want to look at formation of an ester. Okay. So what you do is you start out with alcohol. I'm always going to draw it this particular way. So sorry. So this guy here is called propanol. Okay, what I'm going to do now is I'm going to add the carboxylic acid to it. I'm going to leave the hydrogens off of the carbons. Okay, and this guy is called 1, 2, 3, 4 butanoic acid. Okay, so what happens, just like I showed you in the formation of a triglyceride, you have water pop off, and that forms water. OH, OH, and then what happens is part combines okay, so the alcohol part combines with the carboxylic acid without H, and it forms this structure here. Okay, basically these two, this snapped on this guy just like this guy snapped here. Okay, so how do we name this? The name goes, since this is 3 carbons, it's propyl. And whenever an acid loses its H, it becomes 8. So oic acid becomes 8. So the name of this guy is propyl butanate. And I went through 2 or 3 of these in a lecture before. And so they should be in your notes. Now, the reverse can be done as well, like I said with triglycerides, is that you can take an ester, combine it with water, and break alcohol. And when you do that, that's called hydrolysis, and which is the opposite of esterification. Again, these should be in your notes. Make sure you check them off. All right, and that's the review for alcohols and esters.